Welcome to this another new eDrilling webinar. Today the focus is on optimize your MPD operation. With me I have Ingvild Barås from Halliburton, and I'm Morten Svendsen from eDrilling. Before we start, I will thank you all for joining us for this webinar. In the application we are using, you can ask questions. We will try to answer all of them in the end of the webinar. So in this webinar, we will start by looking at the common drivers for managed pressure drilling. We will also talk a bit about the life cycle drilling simulation in the managed pressure drilling operations. We will talk about the use of the hydraulic model in the planning phase. We will also have a walkthrough through the Halliburton MPD system and how does it work. And in the end, we will look at use of hydraulic model offshore. So, Ingvild, you can start.
A managed pressure drilling technique is a technique that's often used to solve drilling-related problems, such as, for instance, lost circulation. This can occur in depleted reservoirs, in abnormally pressured formations, and unstable formations. It's also a technique which is used for wells where you have a narrow margin between the pore pressure and the fracture pressure. By using MPD, you have increased safety, you get an early influx loss detection and improved well control. By using the MPD technique, you have downhole pressure control and a closed loop system, and you can quickly change your downhole pressure either up or down without any changes to the mud system.
So, as many of you already know, the main concept from eDrilling is the life cycle drilling simulations. And this is also supported for MPD operations. So in the planning phase, we are using the well planner with the managed pressure drilling capabilities. In the training phase, we have the big drill floor simulator, the WellSim Hydro, with managed pressure drilling capabilities, and also the engineering-focused WellSim Interact. And in the operations, we use the GeoBalance, which is the MPD, we call it our MPD set point generator that is implemented into the MPD control system. So we'll talk a bit about these different phases along this presentation.
When discussing with the customer that they want to use the managed pressure drilling technique, we discuss the well, what's planned for the well, and then you do onshore simulations. We then look at what the drilling window is, what the challenges are, and then based on that we determine the optimum mud weight to be able to achieve the objectives for the well. We use the same model both for the online simulations and also the same model and view offshore. What we look at is the boundaries, what would be the minimum target you want to achieve, the maximum, and also where you want to hold the pressure constant. Do you want to hold it constant at the shoe, which is the weakest link, or can be? Do you want to hold it in the middle of a section, for instance, top reservoir, or continuously at the bottom? We often see that in the planning that the drilling works is fine, it can be done, but the challenge comes to either the cementing or the displacement, where you have a high ECD which can result in fracking the formation and then losses. This model that we use can handle up to 20 different fluids, different weights, rheologies, and also different types. And in cementing operations, we can then have several different fluids of this, the cement, the spacer, the displacement fluid, the fluid that was in there already. These are things that we simulate. We work together with the cementing and the mud companies to find the optimum rheology and the weight of the spacer and cement. We also simulate and plan the tripping, pumping and pulling, and displacement in steps.
Yes, and we need to talk a bit about the training part as well. And as some of you already know, the well sim is what we call it's the downhole simulator that is mostly used for training of our products. And we actually have the two ones, as I already mentioned. We have the well sim Hydro, where you have a full-blown topside drilling simulator with cyber chairs and virtual drill floor connected to the well sim real well. So then you build up your real well into the simulator, and you can train your crew on the well that you're going to drill offshore. And when you look at the MPD capabilities that we have in this, in the well sim or the well sim Hydro, is that we have a generic MPD control system to do generic MPD training. But we also have interfaces to Halliburton's MPD system, which we developed a couple of years ago and have been used for several trainings for preparing the crews on Gullfaks and Kvitebjørn. And we also utilize the same interface towards MI Swaco and Weatherford's MPD systems as well, where we also have been doing training for prior to operation. And I think it's worth to mention also that we have the generic dual gradient drilling control system as well, which we also have been used to prepare crews on the Troll field and in the Gulf of Mexico before going into dual gradient drilling operations. Then you have the well sim Interact, which is the engineering focused downhole simulator, where we have kind of the focus is moved away from the drill floor and all the machinery, but it's more on what's happening in the well. And there we have a generic MPD control system as well, but we are also looking into possibilities to interface the different MPD providers' systems as well. And then it can be very suitable to train up new engineers in the MPD company, or also engineers involved in the MPD operations in general. If you look at the features of the well sim products, we have been used it a lot for HPHD, ERD, well control, dual gradient drilling, cold tubing drilling, and so on. So, but benefits about using one of these simulators together with in MPD operation is that it's very easy to configure the real well in the simulator. So you can prepare the crew for the MPD operation on the actual well. And it's also easy to configure the real choke and the flow lines as you are going to use offshore. And that gives you also the possibility to actually get the proper pressures on the surface lines and make it really realistic. And when combining that with having the third party or the MPD provider's control system, you're actually able to train the drilling crew together with the MPD provider crew and on the real well together. Yeah. So to Ingvild.
This is a simplified setup of the equipment that's brought offshore. You've got the normal rigged stack, and then you add on these the red components. You've got the RCD, then we've got a choke with double block and bleed in a skid. There's a flow meter skid, a back pressure pump which constantly flow through the chokes when the rig pumps are off, so that you maintain flow through the chokes at all time. That means that you'll be able to keep the choke within an optimum range, so that you can control the pressure accurately. Instead of a back pressure pump, you can use a rig pump diverter, which gets the flow from the rig pumps from the stem pipe. Then you will not need a pump in addition. Use the rig pumps. The automated choke skid has two fully redundant chokes. If the plugging occurs, the system detects it and the chokes will swap automatically. What will happen then is that the operators tell the driller that a plugging has been detected, pull off bottom, hold constant parameters until the chokes have swapped. If we lose communication to the control system, the choke will maintain the last set point that it was given. We've got a flow meter skid. As the flow is taken out lower down on the stack than conventional drilling, you bypass then the rig's flow measurement. We add in an accurate Coriolis meter, which we use to compare with the flow in signal. Deviance between the flow in and flow out can be seen down to 50 litres, as you see here. Here you got the red is flow out, the blue is flow in. Already here you see that you get a small deviance between them. This is 50 litres, about 70 litres, 100 litres. You then change the bottom hole pressure set point, and the flow in and flow out measurements are accurate again. The GeoBalance system has been designed to maintain constant bottom hole pressure within plus minus 2.5 bar for all normal drilling activities. These include drilling, surge, swab, tripping, displacement, connections, running of a casing liner, and cementing. All of them are done automatically, which means that they're predictable. You're not dependent on a good communication between a driller and a choke operator. Here it's done automatically, and it will be done the same.
Okay, and then when we talk about the well balance, what we talk about then is that we have this dynamic flow model that is used to provide the real-time set points to the MPD control system based on a dynamic real-time simulation. And this model is calibrated against the verified downhole measurements. You can do drag and drop configurations of procedures to be simulated. The model supports dynamic surge slope effects. The back pressure pump is modeled as well in the model. And we also have the cross-application configuration that enables the transfer from. If you do the planning in the well planner with the MPD functionality, you can just copy the well configuration directly over to the real-time well balance, and makes it quite easy. So you don't need to do the configuration many times in different places. And we also have the model state handling that enables the transfer of simulated states. So if you're running the real-time system and you get into some issue, you can take a state from the model that we're running in real time and open it up in the planning tool to actually verify or do changes to see if you can solve your problem. So what we have been doing here is that we have implemented the real-time dynamic hydraulic model into the MPD control system. In this case, it's the Halliburton GeoBalance system. And then we use the input from the rig operations to continuously update ECD and temperature profile in the well. And then we continuously update the choke pressure set point all the time, so the control system can control the choke to achieve the proper pressure on the choke. That will also give you the proper pressure in the downhole where you want it. Okay?
So a little bit again about how the system works. When you come to a connection, the rig pumps and the back pressure pumps have been programmed so that they follow a predefined ramp up and ramp down sequence. So the rig pumps start ramping down, the back pressure ramps up, and this is then the flow that you'll be seeing through the choke. When the rig pumps are off, the rig does what they do to set a new stand, and then the hydraulic model disables the topsides effect so that they aren't taken into account. The model gives the choke a new set point every second. This is a plot from an operation. Here you see 3 connections. The red is the back pressure pump. The blue here is the bottom hole pressure set point. These the dark green are downlinks that have been taken during the operation. There you can see the pressure follows very good. There's very little deviance between the predicted bottom hole pressure and the actual. This peak here is a 2-bar peak. Some operational examples. Depending on what you want to achieve with the well, a dynamic FIT can be done to ensure that you're able to displace to the kill mode that you would like to displace to. So here you've this is the view that the operator will see. They can increase the target set point. They increase, here you can see they gradually increase it. There's no deviance between the flow in and flow out. And the same, you've got a dynamic drawdown test to verify the prognosed pore pressure. You can the pressure is reduced by 2 points, held for approximately 10 minutes. Then you circulate bottom up to verify that there isn't any influx. Then we've reduced it again by 3 points and then circulated bottoms up before continuing to drill. The Halliburton MPD system has data validation built into the system. Data validation is very important as all the input that comes into the system is fed into the system automatically, and a new set point is then calculated every second. Without this data validation, then the system could potentially calculate values based on wrong values. This could be, for instance, a frozen flow in signal. The drilling could continue and the driller could adjust the flow a little bit without then the system compensating for the either increased or reduced flow, meaning that the bottom hole pressure could be wrong over a while, and then you could have either an influx or loss depending on how narrow the margins between the pore and the fractured pressures are. Also, without the data validation, you would not know if the data communication has gone down. Then you would be reliant on the operator noticing it, and an operator, if he gets a lot of telephone calls or there are a lot of things that's going on around him, it might again take a while. So it's important to have data validation to ensure that the input that you get into the system is correct, and if there is anything wrong, either the system tells you that you can't run in automatic mode, or you'll get a warning telling you that something is wrong and you need to take an action. So we've gone a little bit through the MPD system, that it's flexible. You can increase or decrease the bottom hole pressure as needed, depending on if you get an influx or loss. You don't need to, as a conventional system, to weigh up or weigh down. You can use it to take a dynamic FIT. You can use it to take a dynamic drawdown test. As it's automatic, it's accurate, and it's also predictable. The system has been used for drilling both 12¼ inch, 8½ inch, 6 inch, 5 3/4 inch sections. I've used it for displacement with several fluids, running of liner and cementing, all of them done successfully. It's the same hydraulic model that it is used throughout the operation, from the preliminary planning phase at the beginning, also then through the simulator training, the simulations that are done prior to startup, the simulations offshore, and also the real-time operation. This is obviously good for the operators as well that use the system that it's the same, and they don't need to get used to and familiar with several different versions.
So, thank you, Ingrid. We have got some questions, so we will go through some of them. Okay, so the first question, how can the industry build further resilience in the technique, making sure the technique is used correctly? Very good question.
I guess the main thing is that you need to get people to understand the technique, how the technique can be used, getting more knowledge around it so that more fields start to use it. And we see that in operations where they've started to use MPD and they are familiar with the system, they want to use it more and more. They see that it saves them time and then also cost, and it's flexible, which is good.
And I think also by using simulation tools like we provide here is supporting the knowledge. And also I like to kind of pull through the training part of it, where you have a controlled environment where you can see the effects of adding pressure to the well, opening your chokes, and actually being able to do some errors, but also being able to get some losses and heal the losses by lowering your set point and so on, to actually understand what's happening, and that makes it kind of easier for people to understand. So, and also another question, can you elaborate on the differences going statically underbalanced versus overbalanced MPD?
The difference is basically there are some wells where you have a very tight margin between the pore pressure and the fracture pressure, and you would see that if you chose a mud weight that would be statically overbalanced, then once you start your pumps you would have such a high ECD that you would frack the formation. So what you then do is that you design a mud weight that's lower, which is then statically underbalanced by adding the pressure on surface with a choke. You would be in overbalance, and then you would be able to drill through the tight margin.
Okay, and another question, what is Halliburton's experience regarding training of MPD personnel and drilling personnel?
We've been through several stages of training with clients, both from just presentations and workshops where we go through the well and what we're planning to do, and then we've also had the simulator training. The simulator training has been really good, both for the crews to get to know each other, get familiar, and also to practice on the procedures that are going to be used offshore, and particularly also the communication. The communication that goes on offshore during the operation is also one of the keys for a successful operation. They get to practice that, and then also the driller gets to see how the MPD system, how it works and what it does compared with a conventional system.
Okay, another question. What would be the benefit of using MPD as a wellbore breathing mitigation technique in overbalance mode? I think the good thing here is that when you're running a MPD system, you are running a constant pressure at your problem area. So you wouldn't you would be avoiding wellbore breathing mainly. Another question, about your equipment. Are you able to monitor the pressure between the seals in the RCD stack?
Yes, there is pressure monitoring between the seals.
Okay. Does the model account for temperature and cuttings loading? Yes. We could have spent a lot of time talking about the model, but basically the model takes account of all the dynamic effects like temperature and everything that you do to it. And it also has the cuttings loading. So while you are drilling, it builds up cuttings, and it actually is modeling the cuttings concentration along the wellbore. So that is also an output from the model to be used if needed. Let's see, another question.
Yeah, do you have experience regarding optimal cementing systems in MPD mode? What we've done for the cementing operations we've performed is that we go into a close dialogue with the cement provider, and then we do simulations both on the on our simulating tool and on theirs to try and find the optimum both cement weight and cement rheology, and also the spacer that's going to be used to ensure that we achieve what we want to achieve, and that the cementing job is done without loss fuss and successfully.
Okay.
So a question regarding the flow out detection when the Coriolis meter, that when you get gas. What we see is that the Coriolis meter is very good on one phase fluid. It's very good on just the fluids and also on just gas. On a recent operation not long ago, we had gas concentrations up to close to 40%, and we still had good flow out readings. The Coriolis meter didn't, the signal didn't drop out. We had signal readings all the time.
Okay. I think we have gone through all the questions. If you have any other questions, feel free to send Ingvild or me an email. There is a handout in the application here, and that is the presentation that I've put there, so you can have it and go through it yourself. The webinar will also be available on YouTube, so you can also have a review, look at it again. So thank you all for joining us for this webinar.
Thank you.
Okay, bye.